Our sun is 4.6 billion years old. The object that just passed through our solar system and left forever was formed 12 billion years ago. It came from another star system, entirely a star that no longer exists. It carried chemical evidence from the early universe that we have never been able to directly sample. It passed within 130 million miles of the Sunday, and we watched it leave. The question is not what 3I Atlas was. James Webb just answered that. The question is what we decided to do about it, and what that decision reveals about where we are as a civilization. In June of 2026, a planetary scientist named Cordiner sat at NASA's Goddard Space Flight Center in Maryland and looked at data that his team had spent months collecting. Cordiner leads the astrochemistry laboratory at Goddard. His work is about reading the chemical fingerprints of objects in space, understanding what they are made of, and from that, understanding where they came from. When 3I Atlas was discovered in July 2025, Cordiner's team immediately understood what was at stake. This was not another comet from the outer solar system. This object had arrived from outside, from a completely different stellar system, carrying chemistry that formed around a star we have never seen and can no longer find. His team pointed the James Webb Space Telescope's NIRSpec instrument directly at it. They collected the data, they ran the analysis, and on the 22nd of June 2026, they published what they found in the journal Nature. What Cordiner's instrument measured was not what anyone expected. This is that story. By the end of this, you will know exactly what JWST confirmed about 3I Atlas, the specific chemical data, what it means, and why the headlines did not tell you the most important part. You will know why no spacecraft was sent to intercept it, the specific decision that was made, and who made it. And you will know what scientists say has to change before the next one arrives, because there will be a next one, and the window will not be longer. To understand what we just lost, you need to understand what 3I Atlas actually was. On the 1st of July 2025, the NASA-funded Atlas Survey Telescope in Chile picked up a fast-moving object and immediately flagged it as something unusual. Its trajectory was hyperbolic, meaning it was not bound by the sun's gravity. It was not from here. It was passing through. Scientists designated it 3I Atlas. The I stands for interstellar. The 3 means it is only the third object of its kind ever confirmed. The first was Oumuamua in 2017, a mysterious, tumbling, cigar-shaped object that behaved in ways nobody could fully explain. The second was Borisov in 2019, a conventional-looking comet from another star, which arrived, was studied, and left. Neither of them gave scientists what they really wanted. What they really wanted was a chemical sample, a direct measurement of material from outside our solar system, not light reflected off a distant object, but actual spectroscopic data from molecules in its coma, its gas cloud, close enough to read. 3I Atlas was an active comet. It had a coma. It was large enough and active enough to give off detectable chemical signals. And it was arriving at a time when the most powerful infrared space telescope ever built, James Webb, was already operational and pointed at the sky. For the first time in history, all the conditions were met. But here is what made this object different from anything that had come before. Pre-discovery images recovered from telescope archives pushed back the first confirmed observation to the 14th of June 2025. Researchers ran the orbital calculations and arrived at a number that stopped conversations in astronomy departments around the world. 3I Atlas was traveling at 60 kilometers per second relative to the Sunday. That is roughly twice the speed of our fastest rockets. And it was old. Not old the way comets in our solar system are old. Those formed 4.6 billion years ago alongside the Sunday. 3I Atlas was estimated to have formed approximately 10 to 12 billion years ago, around a star that predated our own sun by more than 7 billion years, a star that has long since died. Whatever stellar system produced this object no longer exists in any form we could identify. What 3I Atlas carried, therefore, was not just ice and dust. It carried the preserved chemistry of a cosmic era we cannot directly access in any other way. No telescope on Earth, no spacecraft in our solar system, no instrument built by human hands has ever directly sampled the molecular composition of material from another star system, until Cordiner's team pointed Webb at it. But what JWST found when it looked, that is where the story changes entirely. The James Webb Space Telescope does not take pictures the way most people imagine. Its primary instrument, the NIRSpec spectrograph, breaks incoming light apart into its individual wavelengths. Every molecule in space absorbs and emits light at its own specific frequencies. Webb reads those frequencies like a barcode, identifying exactly which chemicals are present in an object's atmosphere or gas cloud from hundreds of millions of miles away. What Cordiner's team found when they applied that instrument to 3I Atlas was a methane-to-water ratio approximately 11 times higher than any solar system object ever measured. Sit with that number for a moment. 11 times. Every comet we have ever studied, Halley, Hale-Bopp, Churyumov-Gerasimenko, all of them formed in the same broad region of chemical space. They are variations on a theme. Their ice, their dust, their molecular ratios fall within a band of compositions that reflects how our sun and its planets formed. 3I. Atlas was not a variation on that theme. It was from a completely different composition entirely. The methane-to-water ratio tells scientists something specific. It points to a stellar system with a different formation history, a star with a different mass, a different temperature profile, a different distribution of material in its early protoplanetary disk. The chemistry preserved in 3I. Atlas is a record of conditions that no object in our solar system retained. It is, in a precise sense, evidence from a universe we have never been able to read directly. But that is not the finding that should keep you paying attention. Because here is what the methane signal means in practical terms. Methane is volatile. It sublimates. It turns from ice to gas at relatively low temperatures. An object with that much methane ice intact, still actively outgassing after a journey measured in billions of years across interstellar space, is telling us something about where it spent most of that time. It spent it in the cold, in the deep, dark, preserved cold of interstellar space where no star's warmth could touch it, where the chemistry laid down at its formation was sealed, intact, waiting. Therefore, what 3I Atlas carried when it arrived here was not a degraded, radiation-battered fragment. It was a capsule. A chemically preserved sample from the early universe, arriving in our solar system for the first and only time in human history. A mission that reached it, that matched its velocity, collected even a gram of material, returned. It would have been the most scientifically significant sample return in history. More significant than the moon rocks. More significant than the asteroid samples from Hayabusa or OSIRIS-REx, because those samples came from our own solar system, from our own formation history. This would have been from somewhere else entirely. But no mission launched. Not because it was impossible, because of a decision, a specific institutional decision that was made quietly while the object was still in our solar system and the window was still open. When 3I Atlas was first discovered, Avi Loeb, the Harvard astrophysicist who had spent years arguing that interstellar visitors deserved more serious scientific attention, published his immediate assessment. Loeb ranked 3I Atlas a 4 on his classification scale for interstellar objects. 0 means a completely natural comet. 10 means confirmed alien technology posing a direct threat. 4 means anomalous, unusual enough to demand in-person investigation. He was specific about what that investigation should look like. 3. Atlas was traveling at 60 kilometers per second, twice our fastest rocket's top speed. But its trajectory through the inner solar system created a window. A spacecraft launched from Earth in the months following discovery, using a gravity assist from Earth or Jupiter, could have been designed to intercept its path, not to keep up with it, but to catch it at a specific point before it accelerated away. That window, Loeb noted publicly, was the kind of opportunity that comes along not every decade, not every century, but perhaps once in the history of human spaceflight. The proposal was not science fiction. The physics were calculated. Multiple independent teams ran the trajectory numbers. ESA's JWST spacecraft, the Jupiter Icy Moons Explorer, already in space, was in a position to observe 3I Atlas closely as it passed near Jupiter in March 2026. It did observe it. Ground-based telescopes tracked it continuously. The James Webb Space Telescope studied it from 130 million miles away. What nobody did was send anything to meet it. Martin Cordiner, whose team produced the most detailed chemical analysis ever obtained of an interstellar object, was clear about what direct sampling would have added. Webb spectroscopy is extraordinary, but spectroscopy reads light. It infers chemistry from a distance. A physical sample, a single gram, would have revealed isotopic ratios, mineral structures, organic chemistry at a level no telescope in any orbit could ever match. The difference between what Webb found and what a sample return mission would have found is the difference between reading the cover of a book and reading every page. We read the cover, we got the most extraordinary cover ever seen in the history of astronomy, and we have no pages. In October 2017, a telescope in Hawaii called Pan-STARRS detected a faint object moving across the sky at a speed and angle that made no sense. The astronomer who first flagged it was Robert Werrick, a postdoctoral researcher running a routine survey. He pulled up the data expecting to find a standard near-Earth asteroid. What he found instead was an object moving too fast to have originated in our solar system, the first interstellar visitor ever confirmed. They named it Oumuamua, Hawaiian for messenger from afar arriving first. It was already leaving by the time anyone understood what it was. The scientific community spent the next 2 years arguing about what Oumuamua was, its shape, its composition, the unexplained acceleration that made it move faster than solar radiation pressure alone could explain. To this day, there is no consensus, because nobody sent anything to find out. Webb and others later reflected on what had been possible. Oumuamua was discovered late. The window for interception had already closed by the time the object was understood. The failure was not a decision, it was a gap. There was no protocol for responding to interstellar visitors because nobody had built one. That was 2017. After Oumuamua, after 8 years of proposals, papers, advocacy, and planning meetings, after Borisov in 2019 gave scientists a second chance to observe but not intercept the planetary science community, published numerous reports on exactly this question. How to respond faster, how to identify candidates earlier, what a mission architecture should look like, what the funding requirements were. When 3I Atlas arrived in July 2025, those reports existed. The science was done, the case had been made, and the window closed anyway. 3I Atlas passed its closest approach to the Sun on the 29th of October 2025. It swung past Jupiter in March 2026. Cordiner's team published the JWST findings on the 22nd of June 2026. The object is now outbound, accelerating, unreachable. The messenger came. We photographed it through a telescope. We let it go. Here is the thing about 3I Atlas that does not stay in astronomy journals. The decision not to send a mission was not a scientific failure. Scientists knew what to do. The decision was made at a funding and institutional level by the organizations that determine what space agencies prioritize. Those organizations represent you. They operate on your behalf. The window that just closed that was your window too. Here is what we know. Webb confirmed 3I Atlas was chemically unlike anything formed in our solar system. We know a mission was physically possible. We know the window closed. What most coverage has not reached is this. Another interstellar object is coming. Not maybe. The detection rate since Oumuamua tells us it is a question of when, not if. What scientists say needs to change before that happens. That is what is left. After Oumuamua, the scientific community did not sit still. A dedicated working group formed specifically around the problem of interstellar object response. Their conclusions, published across multiple peer-reviewed papers and presented at major conferences, are specific and actionable. The first finding is about detection. Oumuamua was discovered when it was already leaving. 3I Atlas was discovered on the 1st of July 2025, better, but still late enough that a fast response mission required launch preparation that no space agency had prepositioned. The Vera Rubin Observatory in Chile, which began full science operations in 2025, was specifically designed in part to detect objects like 3I Atlas earlier. Its first full operational year produced 3I Atlas within months. This is already an improvement, but earlier detection solves only half the problem. The second finding is about response architecture. A mission to intercept an interstellar object needs to exist before the object arrives. Not as a funded, fully built spacecraft sitting on a launch pad, but as a pre-designed, pre-costed, pre-approved mission concept that can be activated within weeks of discovery, what scientists call a mission in a box. The design work is done. The spacecraft components are understood. The trajectory options are mapped in advance for the range of possible interstellar object velocities and approach angles. No such mission in a box exists today. The ESA Comet Interceptor mission, currently under development and scheduled for launch in 2029, is designed exactly for this purpose. It will be parked at the L2 Lagrange point, waiting for a suitable target. A long-period comet from the outer solar system, or if one arrives in the right window, an interstellar object. The mission exists precisely because of Oumuamua. It is the institutional response to the lesson. But Comet Interceptor will not launch until 2029. It was not in position for 3I Atlas. The gap between lesson and implementation was one interstellar visitor too long. The third finding is about sample return specific. The JWST data from Cordiner's team is, and this is not an overstatement, the most detailed chemical portrait of material from another star system that humanity has ever obtained. But the scientists who produced it are the first to say what it cannot tell us. Spectroscopy from orbit cannot determine isotopic ratios with the precision needed to reconstruct a stellar system's formation history. It cannot identify complex organic molecules at the molecular structure level. It cannot reveal whether the chemistry on board 3, I-Atlas, included the building blocks of biology, the amino acids, the nucleobases, the prebiotic chemistry that some researchers believe may transfer between stellar systems on objects exactly like this one. A gram of material would answer questions that no telescope ever built can answer. The researchers who study this field are not alarmist. They are methodical. But when you read their papers carefully, when you read Cordiner's June 2026 analysis, when you read the detection follow-up studies, when you read the mission architecture proposals, a consistent conclusion emerges. We are living in the window between the first confirmed interstellar visitors and the development of the infrastructure to respond to them. The detection tools are arriving. The mission concepts are ready. The scientific case is made, the institutional response is lagging. 3I Atlas passed through our solar system during that lag. It will never return. The data Webb collected from it is extraordinary, and it is a fraction of what direct sampling would have revealed. That is the verdict. Not a conspiracy, not a failure of knowledge, a gap between knowing and doing measured in one interstellar visitor that came and went while the response system was still being built. It was never really about 3I Atlas specifically. It was about a question that this object forced into the open, a question that Oumuamua raised in 2017 and that Borisov raised again in 2019, and that the scientific community has been trying to answer ever since. What kind of species responds when something arrives from outside? The chemistry on 3I Atlas was 12 billion years old. It formed before our solar system existed. It survived the death of its home star. It crossed interstellar space at 60 kilometers per second for longer than the Earth has been alive. It arrived here at this specific solar system, at this specific moment during the first century in human history when we had the instruments to detect it, the telescopes to study it, and the rocket technology to theoretically reach it. And we studied it from a distance, we got the cover, we read the wavelengths, and we let it go. The next one is coming. The Vera Rubin Observatory will find it earlier. ESA's Comet Interceptor may be in position. The mission architecture will be better. What Cordiner's team published on the 22nd of June 2026 is not just a chemistry report. It is a record of what we could read from 130 million miles away, and an implicit map of everything we could not. The window is not permanently closed. It just closed this time. Next time, we are looking at Voyager 1. Right now, in July 2026, NASA's engineering team is attempting a procedure they have called the Big Bang, a last-ditch effort to keep the most distant human-made object alive long enough to reach a milestone no spacecraft has ever reached. If you want to know whether it worked, subscribe. That one is coming soon.